Hello everyone. Today in our video clips we're gonna start chapter 5. Basically in chapter 5 it's all about trig identities. Okay, and in my opinions I claim that this is the most important chapter to help you to prepare for your calculus classes, because you guys are going to use quite a number of trig identities in calculus. Okay, so it's good if you prepare it ahead of time. Alright, so today we're gonna start with our first three sections of chapter 5, 5.1 to 5.3. So basically on 5.1 and 5.2 we're gonna show you some basic or fundamental trig identities, and on section 5.3 I'll show you the sum and the difference angles in the cosine identities. Okay, so first of all I'm gonna give you all the equation, the formulas section from 5.1 to 5.3, and then I'm going to show you some typical examples that help you to practice and master your skills. Okay, and I claim that really mathematics, so you really need to practice. Okay, one more time, have any question, please don't hesitate to ask. But my point is, watching the video clip and copy down all the identities is not going to be enough for you. And just a couple examples on the board for 10-15 minutes is not going to be enough at all. You guys really need to spend some time and then practice as many as you can. So let's start with some fundamental identity. Let's start with the reciprocal one. Say we have tangent of x or alpha, whatever. Tangent is reciprocal of cotangents. Okay, secant is a reciprocal of cosine. Cosecant is a reciprocal of sine. Okay. And tangent is sine over cosine. Of course, cotangent is the reciprocal, so it's going to be cosine over sine. Okay. What else? Pythagorean. So what? Sine square of x plus cosine square of x is equal to 1. Okay, this is the basic one. Now if you divide both sides by sine square, you got 1 plus cotangent square of x equal to 1 over sine. It's going to be cosecant square of x. Divide both sides by cosine, you got cosine square, right? Tangent square of x plus 1 equal to secant square of x. Those three right here are equivalent. Pythagorean identities. Okay? And then what if you have the negative sign, so it's even or odd functions? We have what? Cosine is even, so cosine of negative x is equal to cosine of x. Sine of negative x equal to negative sine of x, because sine is odd. Tangent and cotangent are both odd, so tangent of negative x equal to negative tangent of x. Cotangent of negative x equal to negative cotangent of x. Okay. And secant is reciprocal of cosine, so it's going to be even. So secant of negative x is equal to secant of x. See? For even function, you change the sign, it's the same. For odd function, you change the sign of the angle. You have the opposite one, value outside. So cosecant, this is my c, okay, of negative x equal to negative cosecant of x. Those are the fundamental or basic equation that you guys are going to need. Okay. And let's move on to the sum and difference for the cosine angles, for the angle of cosine. So let's move on. Let me erase this. I'm just giving you all the formulas necessary for our lecture today, and we're going to practice some exercises. Okay. Cosine of the angle, say A plus B, is cosine A times cosine B minus sine A sine B. cosine of A minus B is equal to cosine A times cosine B plus sine A sine B. Okay, so see in here, cosine of the sum of two angles. If you want to break it down, it's going to be cosine A, cosine B, and then minus, okay? Change from plus to minus to sine A, sine B. And then for cosine of A minus B, you change to cosine A, cosine B, plus sine A and sine B. And those are all the formulas that you guys will need to know in our video clip today in our sections 5.1 to 5.3. This is all about 5.3, I claim, but we're going to extend this a little bit more. What if you have something, examples, okay? Cosine of 90 degree. Let's do radian then. Pi over 2 plus x. Can you simplify this? We can use a formula right here. Cosine of A plus B, where A is pi over 2 and x is B. This is going to be cosine of pi over 2 times cosine x minus sine of pi over 2 times sine x. Okay, see? Cosine A, cosine B minus sine A, sine B. I'm using the first formula right here. And you know what cosine of pi over 2 equal to? Cosine of pi over 2 is 90 degrees 0, so this is 0. Okay, 0 times whatever is 0. So sine of pi over 2 is 1, so this is 1. So this is equal to cosine of pi over 2 plus x, really equal to negative sine x. You see the relationship between sine and cosine. Look at the angle 90 degrees. Okay, you have it. And of course you can have what? Pi over 2 minus x in here. So what if I change this to minus, and this become plus, this become plus right here. You have another formula. Okay, so cosine of pi over 2 minus x equal to sine x. You have a bunch of formula that makes sense. It's what we learned before. Okay, and the book gives you the formula for those, but I claim that I don't need to, because you can derive from here. You have this. But A is pi over 2 and B is x. And plus or minus, apply the two formulas. You have the answers. Okay? But it's good if you're trying to remember all of them. That's fine. Okay? So the book writes this. Cosine of pi over 2 plus x equals negative sine x. Cosine of pi over 2 minus x equal to sine x. Okay? And of course, sine, you have the same thing. Let's learn that later in section 5.4. For now, it's good enough. Okay, let's take a look at a couple exercises. I'm going to show you some typical examples only, all right, that you guys are going to see in the homework. The first type of problem you will see that I think is important. Okay, a lot of exercises you guys are going to see in the homework. But first type is verifying a trig identity. In other words, they give you the trig identity, left-hand side equal to right-hand side, and they ask you to verify. Try to prove. Okay, so let me look for an example and I'll show you one. Okay, how about this? Start with an easy one. Show that cotangents of theta over cosecant of theta is equal to cotangent of a cosecant equal to cosine theta. Is that really true? Verify that identity. And it's not applicable all the time, but I would say that most of the time, or many times, whenever you see trig identity, you should try to bring it back to sine and cosine, because trig function, sine and cosine, or even tangent, usually sine and cosine, will take care of the problem. Okay? So that was the first thing that you should try, or at least I would try. So let's try to simplify this. Right? Cotangent is what? Cosine over sine, right? Over cosecant is what? Cosecant is 1 over sine. 1 over sine theta. Yeah? So we have a fraction divided by another fraction, means multiplied by the reciprocal. So this is cosine of theta over sine of theta divided by fraction, means multiplied by the reciprocal, which is sine of theta over 1. Now we see that the sine of theta cancels out, so it's really equal to cosine theta. So you guys see the first type of problem right here. We really try to prove that the left-hand side equal to the right-hand side. They call it what? Verify the trig identity. So we're going to verify that really the left-hand side of the fraction right here equal to cosine theta. And this is how. Okay, in this particular problem, what I did was I converted everything back to sine and cosine, and I simplify. Not all the problem going to work this way, but I claim that many. Okay. Let's try another one. Pick someone that's the higher number, so it's harder. I'm just looking at our textbook, and I'll just randomly choose a question. Okay, choose another one. Cotangent 1 over sine 1 over 1 minus sine theta plus 1 over 1 plus sine theta. Show that this is going to be equal to 2 secant square theta. Alright, so I have no clue, so let's first do what the what I have in mind is what change it back to sine and cosine. So this is sine already, so let's convert secant to cosine. Alright, so this is 1 over 1 minus sine theta plus 1 over 1 plus sine theta is equal to 2 over cosine square theta, because secant square is 1 over cosine square, right? Alright, so what? We have two fractions on the left, one fraction on the right, so let's simplify in here. See what we can have for the fraction. How do you add the two fractions together? We're going to look for the common denominator, so we need to multiply this 1 by 1 plus sine theta, this 1 by 1 minus sine theta. So the common denominator is going to be 1 minus sine times 1 plus sine theta. Sine theta. Well, at least I can combine the two fractions, becomes 1. Hopefully I can simplify more. So what I have in here is 1 plus sine theta plus 1 minus sine theta, and the denominator is 1 minus sine theta times 1 plus sine theta. Okay? And then you multiply them all out, and then you combine the right term on the denominator and simplify the numerator, see what you got. But I see there's another formula that's pretty handy for your learning in here. You got a squared minus b squared equal to a minus b times a plus b. Remember the conjugate multiplying. This is right, the conjugate pair. Okay, a minus b times a plus b in the complex section is going to be a squared minus b squared. I think we talked about that before. I see the bottom right here, 1 minus sine, 1 plus sine is 1 squared minus sine squared. And the top is what? 1 plus 1 is 2. Sine minus sine cancel out, so 2 over 1 squared minus sine squared. Oh, theta. Give me the answer. Remember the Pythagorean identity? 1 minus sine squared is cosine squared, because now I'm using what? Sine squared theta plus cosine squared theta equal to 1. So 1 minus sine squared is cosine squared. So this is really 2 over cosine squared theta, which is 2 times secant squared theta. Alright, see, there are two examples. We see the type of problem that you guys are gonna work on those homework. And I claim it's pretty important, okay? Because when you guys move on to calculus, there will be very little time for the instructor to come back and review all the trig identity for you. They will assume that you guys know some already, so we're going to move on pretty quick. So please take your time, spend your time now, and learn those identity, okay? And practice. This, I would say the best way to master all your formulas is to practice. Okay, similarly, you can try the others. All right, let's move on to the exercises for the sum or difference of cosine. Show you, how about 2 more? Many of them, okay? Just practice. You got stuck, you have difficulty, please just let me know. How about this? Calculate cosine of 15 degree. What is that equal to? All right, interesting question. I don't know, top of my head, the cosine angle of 15 degree, but I can modify 15 degree as cosine of How about 45 degree minus 30 degree? Because I know the values, the trig values for 45 degree and the trig values for 30 degree, so I can calculate 15, right? So cosine of 15 degree is the same thing as cosine of 45 minus 30. And according to the formula that we learned already, this is cosine of 45 degree times cosine of 30 degree plus, right? For cosine minus become plus, sine of 45 degree times sine of 30 degree. Okay? And we know the cosine of 45 degree is root 2 over 2. Cosine of 30 degree is root 3 over 2. Plus sine of 45 degrees root 2 over 2. Sine of 30 degree is 1/2. So this is root 6 over 4. Root 2 times root 3 is root 6. 2 times 2 is 4. Plus root 2 over 4. Okay, that's the answer. You see? Even though we don't have it right away, but we can use the sum of different angles for cosine. We can figure out. Are we good? You can try this one. I'll just give you. How about cosine of 75 degree? You can think of it as cosine of 45 degree plus 30 degree. Or you can even think of this as cosine of 90 degree minus what? 15 degree. Now, we know 15 degree right here. We can apply right here, right? We can have the answer, but I claim the first way is better because you use straightforward 45 degree and 30 degree, as you know previously. 15 degree we just learned right here. Root 6 plus root 2 over 4. 75. Root 6 plus root 2 over 4. Okay. Fair enough? All right. Let's move on to another type. And this is the main one that I want you guys to see. Okay, let me look for an example. They're gonna give you two angles S and T. They give you let me see. S and T is in quadrant number 2. S and T is in quadrant number 2. Okay? Means what? The angle is somewhere between 90 to 180 degrees. Okay? So this is your unit circle. Quadrant number 2 is right here. Any angle right here. S and T means what? Sine going to be a positive value and cosine will be a negative number. Okay? That's what you should know if the angle is in the second quadrant number 2. Okay, and I gave you this. Sine S is equal to, let me look, make sure I got it right, equal to negative 1/5. How can it be? I'll copy it. Sine S. Oh, I copied it wrong. Cosine S. Cosine S. Cosine S is negative 1/5. This is a lot of problem here. Negative cosine. Negative 1 over 5. And then sine T is equal to 3/5. Equal to 3 over 5. Make sure that I copy it right. Alright. And the question asked is what? Calculate cosine of S plus T. And then calculate cosine of S minus T. Okay, so they give you cosine of S, cosine of T. They ask you to calculate cosine of S plus T, cosine of S minus T. Alright, here you guys going to apply the sum of different angles for cosine trig function in here. Let's do the first one, cosine of S plus T. Cosine of S plus T is what? Cosine of S times cosine of T minus sine of S times sine of T, right? Remember, cosine of A plus B, cosine A, cosine B minus sine A, sine B. What do you know already? You know cosine of S right here, this is negative 1/5. You know sine T right here, this is 3/5, alright? So if you want to solve the problem, you need to calculate cosine T and then sine T, and you should have the answer. Okay, And here is my favorite part that's going to help you to prepare for your calculus course. How do you figure out those things? Let's start with cosine S. We have, let's see right here, okay. We have cosine of S equal to -1/5. And the strategy is this. You're going to draw a right triangle. The angle is S. And you know that cosine is adjacent over hypotenuse. So cosine of S is -1/5. Just forget about the negative sign right here. Just triangle, so just a positive term, okay? So 1 and 5 right there. And we know that quadrant number 2, cosine, we'll bring it back to negative later. Okay, so S is the angle. Opposite is 1. Hypotenuse is 5. Adjacent over hypotenuse. So can we calculate the opposite side of the angle? Yes. What? Pythagorean theorem. This is we'll call it x, right? X squared plus 1 squared equal to 5 squared. So x squared equal to 25 minus 1 equal 24. So x is square root of 24 is 2 root 6, I think. Yeah. Okay, so this is 2 square root of 6. All right. So you got cosine of S equal to -1/5. So sine of S, we're talking about this part right here. Sine of S is what? Opposite over hypotenuse equal to 2 square root of 6/5. Now we got to check for the sign and see whether it's positive or negative. Since the angle S is the quadrant number 2. Quadrant number 2. All right. So cosine is negative, but sine gonna be a positive number. So we have the right answer. We got it right. Sine of S is 2 root 6/5. Similarly, you do the same way for the second angle. How about T? What did they give you? Sine T is equal to 3/5, right? And we do the same idea, same strategy. We construct a right triangle. The angle now is T. And sine is what? Opposite over hypotenuse. Opposite is 3. Hypotenuse is 5. Okay? So we can find the adjacent. Obviously, this is 4. Very famous right triangle, 3, 4, 5. So we can calculate cosine of T. Cosine of T is adjacent over hypotenuse, so 4/5. Okay? So the main point I tried to bring to you is right here. You are given sine, you can calculate cosine, and vice versa. Same thing for tangent and cotangent. What if I give you tangent, then what? Tangent is opposite over adjacent, right? Cotangent is adjacent over opposite. Okay, you have this. Plug them in. Cosine of T. Oh, by the way, cosine, is that positive or negative? Ooh, that's important. We forgot it. Quadrant number 2. Cosine of T will not be 4/5. It's going to be -4/5 because it's on the second quadrant. Okay? So, cosine of S is -1/5. Cosine of T is -4/5. And then subtract. Sine of S is 2 root 6/5. And sine of T is 3/5. Now simplify. This is what? Negative times negative positive. What is it? 4/25 minus 2 root 6 times 3 is 6 root 6/5. So this is 2 minus 6 square root of 6/5. And of course, this is a very typical example. You guys can apply the same strategy, same step to work on other problems. Could be sine, cosine, could be different quadrants. So sine and cosine may change the sign. Okay, could be positive, could be negative. But the idea is right here. Exact same thing. All right, and this is all. Hopefully, the example is going to help you to practice your homework. And as I'm saying at the beginning, this is mathematics, so please spend some time to practice. Okay, the more you practice, the better you're going to be. Thank you for watching, everyone. Have a good day. Any question, feel free to ask.